Now we have to study velocity time graph, which is also known as VT graph. So first case we have velocity time graph for uniform motion. So let us take one example to understand it. Okay. Now uniform motion means velocity of the object is not changing. So let us mark a few points here, A, B, C. Okay. Now consider observer is at point O and object is at point A. When observers start observing the object, its velocity was 2 meter per second at time t is equal to 0. It is the starting time when the observer start observing the object. Okay. Now after time 1 second, object was at point B and its velocity was 2 meter per second. Now at point C, when time was 2 second, object reached at point C and passed this point C with velocity 2 meter per second. Now you see, for this observer who is standing at point O, at point A, velocity of the object is 2 meter per second. At point B, velocity is 2 meter per second. At point C, velocity is 2 meter, 2 meter per second. Now, here we are not talking about the distances. Okay, we are talking about the velocities. So velocity of the object is constant or uniform at every point. So it is the example of uniform motion. Now let us draw a graph, that is velocity time graph. So time t along x-axis and velocity v along y-axis. So just see the nature of the graph. So it is second 1, second 2, second 3, second 4, and say it is 1 meter per second, 2 meter per second, 3 meter per second, because along y-axis we are taking the velocity. Now when time t is equal to 0, velocity of the object is 2 meter per second. So time is 0, velocity is 2 meter per second, so point is marked here. Now when time is 1 second, again velocity of the object remains same. There is no change in the velocity. So when time is 1 second, again the velocity remain 2 meter per second. When time is 2 second, again velocity of the object remains same. There is no change in velocity, so point is marked somewhere here. If we join all these points, we'll obtain a straight line parallel to x-axis. So it is the velocity time graph for uniform motion. So let us draw the general graph here. So velocity time graph for uniform motion is given by a straight line. So it is x-axis, it is y-axis. Along x-axis time taken in second, and along y-axis we have velocity which is taken in meter per seconds. So graph is a straight line which is parallel to time axis. Okay, now it's very important thing. If O be the origin here, O be the origin here or reference point, okay, now we can write the nature of graph here. That what is the nature of graph? So mind it, here you can take the velocity v or v1 v2 whatever you can. Now nature of graph here, graph is a straight line parallel to either you can say x-axis or time axis. Why it is known as time axis? Because time is taken along x-axis. So you can write x-axis or time axis. So what is the nature of velocity time graph or VT graph for uniform motion? So it is a straight line parallel to time axis. Now we have to see what is the significance of this graph, VT graph, for uniform motion. Significance or importance of the graph. So it is significance of the graph. So let us draw graph here, that is velocity time graph for uniform motion. So x-axis and y-axis. Time is taken along x-axis, velocity in meter per second is taken along y-axis. So I think it is the graph which is a straight line parallel to time axis. Now let us mark the points here. Suppose point O, say it is a point A. You can mark another point here, B, and drop a perpendicular on x-axis. So suppose it is your point C here. Okay. Now slope cannot be taken here because this straight line is not making an angle with x-axis. Instead, it is parallel to the x-axis. But we see area under this graph. If you see, we have area under this graph. So in the significance of this graph, we'll find the area under this graph. So let's mark here. Along x-axis, we are taking the time here. So at point C, suppose time is t. And now see here at point A, we are marking velocity here. So let us mark velocity v here. Okay, now let us find area under this graph as a significance. Area under the graph. So area under the graph is equal to length into breadth. So length is equal to, you can take OC, into breadth you can take OA. So OC into OA. Now see, OC is equal to time t and OA is equal to some velocity v. So area under the graph gives us time into velocity. That is time into velocity. Now, because we all know from the definition of velocity, velocity is equal to displacement upon time. So from this equation, displacement is equal to velocity into time. Velocity into time. So velocity into time is equal to displacement. So here time into velocity should be equal to displacement. So finally you can write area under the graph gives us time into velocity. Time into velocity means displacement. Right? So it is all about the significance of the velocity time graph for uniform motion. So area under velocity time graph for uniform motion gives us displacement. You just have to find the area under this graph. So area comes out to be time into velocity, and you must know time into velocity is always equal to displacement. So area under the graph gives us displacement. Right? Now we are going to study the another case for velocity time graph, that is velocity time graph for uniformly accelerated motion. Now you see, we can draw a general graph, that is velocity time graph for uniformly accelerated motion. It is x-axis, it is y-axis. So time in seconds is taken along x-axis and velocity in meter per second is taken along y-axis, like that. Okay, now before drawing this graph we have to understand what is uniformly accelerated motion and how its graph is obtained. Okay, so let us take one example here. Okay, now just see what we have here. Uniformly, then accelerated, uniformly accelerated, right? Means uniformly means same, that is constant, and accelerated means change in velocity. Means we are talking about such motion in which there is change in velocity, but that change is constant. That change may be increase or decrease. So let us take one example here. Just say like that. Okay, so mark one point O here, point A, point B, and point C here. Now suppose here time t is equal to 0 and velocity of the object is 0. It means observer and object both are at point O. When time t is 1 second, velocity of the object becomes 2 meter per second. Okay, now you see velocity of object is changing from 0 to 2, right? Now when time is 2 second, velocity become 4 meter per second, right? Now when time is 3 seconds, velocity of the object, suppose it is 6 meter per second. Means velocity of the object is changing, and here change means velocity of the object is increasing. But you see, for every second how much velocity is increasing? Just see, from O to A, increase in velocity is 2 meter, 0 to 2. From A to B point, at point A velocity is 2 meter per second, and at point B velocity is 4 meter per second. Means again for the next second, for the next 1 second, change in velocity is 2 meter per second. And from B to C, again you see the change in velocity is 2 meter per second. Means इस ऑब्जेक्ट का जो वेलोसिटी चेंज हो रहा है हर सेकेंड में, वो 2 मीटर पर सेकेंड चेंज हो रहा है, 2 मीटर पर सेकेंड चेंज हो रहा है. मतलब चेंज तो हो रहा है, change in velocity is there, but that change is constant. So it is the example of uniformly accelerated motion. Now let us draw a graph, velocity time graph here. So time along x-axis, velocity along y-axis, x-axis and y-axis. So O be the origin here. Time, suppose 1 second, 2 second, 3 second, 4 second. And velocity say 1 meter per second, 2 meter per second, 3 meter per second. Now let us draw a graph. When time t is equal to 0, velocity is 0. Means point is marked somewhere here. When time is 1 second, velocity is 2 meter per second. For 1 second, velocity is 2 meter per second. So point is marked here. When velocity is, time is your 2 second, then your velocity is 4 meter per second. So let us take only 2 points here, like that. Okay, so when we join all these points, we'll obtain a graph like that. So this graph is a straight line which is inclined to x-axis. Inclined means which is making an angle theta with the x axis. Okay, it is the first example of uniformly accelerated motion. Okay, let us take another example here. Suppose O point, then you have a point A, you have a point B, you have a point C, right? Now suppose, okay, now suppose observer is at point O and object is at point A when observer start observing the object. And suppose at that time t is equal to 0, when the observer start observing the object, it has a velocity of 2 meter per second, and after 1 second velocity becomes 4 meter per second, and for the next second, that is when time is 2 second, velocity becomes 6 meter per second. So again you see velocity of the object is changing at every second, and this change is uniform. Means at every second velocity of the object is increased by 2 meter per second. हर इंस्टेंट में, हर सेकंड के बाद इसका जो वेलोसिटी इंक्रीज हो रहा है वो कितना हो रहा है, 2 मीटर पर सेकेंड. सो आई थिंक इट इज ऑल्सो द एग्जाम्पल ऑफ यूनिफॉर्मली accelerated motion. So let us draw a graph for this situation. So x-axis, your y-axis, time and velocity. So time 1 second, 2 second, 3 second, and it is 0. So here 2 meter per second, 4 meter per second, 6 meter per second. Okay. Now when time t is equal to 0, velocity is 2 meter per second. टाइम t इज इक्वल टू 0, वेलोसिटी इज 2 मीटर पर सेकेंड. ये पॉइंट यहाँ पर आ गया. व्हेन टाइम इज 1 सेकेंड, वेलोसिटी इज 4 मीटर पर सेकेंड. सो वी हैव अनदर पॉइंट समवेयर हियर. एंड व्हेन टाइम इज 2 सेकेंड, velocity is 6 meter per second. So you can mark another point here, somewhere here. So we have again a graph which is a straight line parallel to time axis or x-axis. So I think these two graphs, both these two graphs are valid for uniformly accelerated motion. So let us draw the general graphs here. It was just an example to understand. So now let us draw velocity time graph for uniformly accelerated motion. So it may start from the origin. Oh, right? Now another graph, velocity time graph for uniformly accelerated motion. So you can draw like that. It is x-axis, here you have y-axis, time in second along x-axis, velocity in meter per second along y-axis, and you can start the graph from somewhere here, and here you have velocity v here, right? Both these two graphs are valid for velocity time graph for uniformly accelerated मोशन. ये दोनों ग्राफ आपके वैलिड हैं, दोनों में से कोई भी आप ड्रॉ कर सकते हो. बस ये ग्राफ हमें बता क्या रहे हैं, ये ग्राफ हमें बता रहा है कि ऑब्जेक्ट और ऑब्जर्वर एक ही पॉइंट से बिलोंग कर रहे हैं, और ये वाला ग्राफ हमें बता रहा है कि ऑब्जेक्ट और ऑब्जर्वर जो हैं उनके बीच में एक डिस्टेंस था. ओके, तो अभी हमें करना है सिग्निफिकेंस ऑफ वेलोसिटी टाइम ग्राफ फॉर यूनिफॉर्मली एक्सेलरेटेड मोशन. तो वो हम नेक्स्ट लेक्चर में करते हैं.